In this video, we'll look at a review on lines, slope, coordinates, and mainly equations of a line. I won't go that in depth in all the concepts that you would look at in this chapter in school, but let's just dive in. Now, say you have 2 points, A and B, in the XY plane, right? So if you draw something very basic, let's say A and B. You often want to know the change in the x coordinate, right? The horizontal distance in going from A to B, right? Obviously, A is right here, so you would have the x coordinate there, and for B, you would have the x coordinate right there. Now you want to know that change. What does that mean? Well, you would write it like this. Okay, what is that? That's the triangle. Well, that is the capital delta in the Greek alphabet. Delta is referred to as the change in x. Okay, it can be read as the change in x, but usually it's read as just delta x. The point is that delta x denotes a single number. It's a single number. Don't think that you have the triangle representing a number and then you have that number next to x, meaning multiplication. No, it just means the change in x. Similarly, you also have change in y. Okay, now let's make this plot a little bit better. You have y in the vertical and x in the horizontal. All right. Now let's say you have A is 2, 1, and B is 3, 3. Don't worry about the scale of the image. We're just going to work with the numbers, with the coordinates. All right. So the change in x here would be this distance right here. What is the value of that distance? Well, if you know that this is 3 and this is 2, well, that's just the difference between the two. Delta x is 3 minus 2, that is 1. The change in y will be the same thing. That's going to be the distance between this point and this point. If you know this is 1 and this is 3, that is the difference. 3 minus 1, that is 2. So the change in x is 1. The change in y is 2. In a general sense, the equation for the change of x would be x2 minus x1, and the change in y would be y2 minus y1. If you combine these, though, you're going to end up with something called the slope. The point of using 2 distinct points is the next concept wouldn't exactly work if you have the same point working with itself. Okay, you'll see what I mean. You can draw one and only one straight line through those 2 distinct points, right? So you have A and B. You can draw a line between those two. By the slope of that line, that is going to be the ratio of delta y to delta x. All right, that's the slope. Ratio of delta y to delta x, and it's usually denoted with the letter m. So m would be the slope. That is going to equal to the ratio of delta y to delta x. You already know what delta y and delta x are. So you have y2 minus y1 over x2 minus x1. Now, you can also use 2 keywords that are famous when you're defining the slope of a line. That is going to be the rise over the run. Rise meaning the vertical distance and run meaning the horizontal distance. Let's do an example. Let's say you have a line joining 2 points. Let's say the points are 1, -2, and 3, 5. What is the slope between these 2 points? Well, you would do m equals y2 minus y1. Well, y2 is 5 minus y1, which is -2, over the delta x, 3 minus 1. Okay, at the top you have 7 over 2. So the slope is 7 over 2. That means for every 2 units you travel horizontally, you're going to travel 7 units up. 7 units in the vertical sense. Now you have your slope, which is going to be part of the equation of a straight line. And the first kind of equation that students study is what you'd call the y equals mx plus b form. All right. So what is that? So if you write y equals mx plus b, don't worry if you don't understand this right now. We're going to break it down. The m is obviously your slope. All right. So that means if you increase x by 1, notice how m is a number and x is your variable. There's multiplication here now. If x increases by 1, this equation tells you that you have to increase y by m. All right? If you increase x by delta x, which is a number, then y increases by m times delta x, which is, in a sense, delta y. The number b is called the y-intercept. Okay, so if you break this down, that's going to be the slope. This is the y-intercept. What is the y-intercept? Well, that is where the line crosses the y-axis. And whenever you are at the y-axis, the x-coordinate is always going to equal 0. So whenever x equals 0, that is your y-intercept. If you know 2 points on a line, the formula m equals y2 minus y1 over x2 minus x1 gives you the slope. Once you know a point and the slope, then the y-intercept can be found by substituting the coordinates of either point in the equation. All right? You have a point that is known and a slope that is known. You only have one unknown, which is b, the y-intercept. Once you substitute all of those, you are definitely able to find the value of b. Alternatively, one can use the point-slope form of the equation of a line. And that means you're starting with y minus y1 over x minus x1 equals m. Then you multiply both sides by x minus x1. And then you get this. You get y minus y1 equals m times x minus x1. This is called the point-slope form. Why point-slope form? Well, you have a point, which is y1 and x1, and m. Once you solve this equation, you'll end up with the y equals mx plus b form. It is possible to find the equation of a line between 2 points directly from the relation of the slope, which says the slope measured between the point x1, y1 and the point x2, y2 is the same as the slope measured between x1, y1 and any other point on the line. Okay, what does that mean? Well, let's draw a diagram here. Let's say you have A and B, where you know what the coordinates of A are, but you're not exactly sure what the coordinates of B are. And let's say you're asked to find the slope between A and B. Well, let's say you know another point, and let's say you know what the coordinates of C are. The slope from A to C is going to be exactly the same as the slope from A to B, because they're all on the same line. All the points are on the same line, and since it's a straight line, it's going to have one slope. It's not changing in direction anytime soon. For example, if you want to find the equation of the line joining the earlier points, A 2, 1, and B 3, 3, you can use the slope formula. You have m equals 3 minus 1 over 3 minus 2. You have 2 over 1, so I'm not even going to write 1 in the denominator. I'm going to leave it as such. That's just the slope of 2, meaning that the rise is going to increase by 2 units every time you increase the run by 1 unit. If you use the formula above, the point slope form, you have y minus 1 equals 2, which is the slope, x minus 2. You could use either point though, and you'll see that shortly. You have y equals 2, x minus 4 plus 1, and then you end up with 2x minus 3 as your y mx plus b form, as your equation. Now you could use the other point. Let's use another color. You could do y minus 3 equals 2x minus 3. In this case, you have y equals 2x minus 6 plus 3, and you end up with y equals 2x minus 3, which is exactly the same as what you got previously.